In this video, we'll look at tables and grids and their use to represent sample spaces. Tables and grids are visual representations of sample spaces. They can be used when there are two events taking place in a multi-stage experiment. Examples of multi-stage experiments that can be used with tables and grids include rolling two die, flipping two coins, or rolling a dice and flipping a coin at the same time. The third example is shown here, where across the top we have the number that would be face up on the die, and down the first column we have the face of either the head or the tail that is pointing up on the coin. If more than two events need to be represented, a tree diagram could be used instead of a table or grid. So next we're going to look at rolling a pair of die. In the grid to the right, represent the possible outcomes when rolling two die. So we're just going to look at what is facing up in each case. So here we could have 1, 1, we could have 1, 2, we could have 1, 3, so on and so on. And this one would be 2, 1, until you get all the way to 6, 6. Now to speed up, I've got a computer to generate this for us. So with that in mind, the first part of the question asks, what is the probability of rolling at least 1 6? So if we have a look at our grid, this represents the sample space. And rolling at least 1 6 includes all of the elements down here. And it also includes the elements through here. So with that in mind, if we count these up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 outcomes that satisfy our probability of rolling at least 1 6. And across the grid, there are 36 possible outcomes. So the probability is 11 on 36. For part B, we're asked, what is the probability that both numbers are even? So if we want both numbers to be even, we need to look for those particular cells in the grid that satisfy that event. So we can have 2 2, 2 4, and 2 6, but nothing that contains a 1. So that excludes that first row. Then all of these have 3's in them, so the third row is out. Then we can have 4 2, 4 4, 4 6, and similarly we can have 6 2, 6 4, and 6 6. Therefore, our probability is 1 2 3 4 5 6 7 8 9, which satisfy our event, out of a total of 36, which can simplify down to a quarter or a 25% chance that you'll get both die having an even number. For part C, we want to find the probability of rolling a double. So our doubles are on this diagonal, where you get a 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. And all up, there's 6 outcomes over a possible 36 in the sample space, which simplifies down to 1 on 6. So that's the probability of rolling a double. So if we throw our minds over to Monopoly for a second, we could ask, what's the probability of going to jail by rolling 3 doubles in a row? So you could represent this on a tree diagram. So here you could throw a double, or you could not throw a double, so the complement of D. Then you could throw a double, or not a double. And lastly, you could throw a double or not a double. So in this case, we then have 1 on 6, 1 on 6, and 1 on 6. And we multiply across our branches to give 1 on 6 times 1 on 6 times 1 on 6, which is going to equal 1 on 216. And now, just for your interest, if you wanted to know what that is as a decimal, it would be 0.00463, and it goes on and on. So there's a very, very small probability of you actually going to jail by rolling 3 doubles in a row, but it is possible. So after this video, you should be able to know when to select tables and grids to represent a sample space. You should be able to use tables and grids to visually represent sample spaces and events in them. You should be able to use tables and grids to determine the probability of an event occurring. And finally, you should understand the limitations of tables and grids and alternatives that can be used to overcome these.